And welcome back to our videos. We're going to start here with writing linear equations. Today we'll start with writing linear equations in slope-intercept form, which is something you are familiar with. It hasn't changed. It is still y equals mx plus b, where the slope is represented by m and the y-intercept is represented by b. The first example here is the most basic that we'll have. It says write an equation of the line whose slope is -2 and whose y-intercept is 5. So in order to do that, we use y equals mx plus b. So we have y equals mx plus b. Here my m is -2 and my b is 5. It's as easy as going y equals -2x plus 5. And that's all you would need to do. So as I said, this is the most basic, straightforward of the types of equations that we will be writing here in the next few days. But take advantage of these because there will be some of these on your exam, and we do need to be familiar with the slope-intercept form. Taking this to a different display here is we want to write the equation of this line. Okay, so again, in slope-intercept form is y equals mx plus b. So the first thing I want to do is I want to identify my y-intercept. I look at the graph there, and that seems to be the point 0,2. Whoops. Change that color. So that would give me b equals 2 in this case. And from there, I need to find another point that I know so I can find my slope, and it seems to be the point 4,3. The easiest way that I think to calculate the slope is to go from your point furthest to the left, so 0,2. We have to go up 1. So that's a rise of 1, and then we have to run 1, 2, 3, 4. So that's a slope of 1/4. So our m is rise 1, run 4. So that means our equation is y is equal to 1/4 x plus 2. And that's the equation of that line. And that's how you would pull it from the graph of a line. Identify the y-intercept, identify another point, and then rise and run to calculate your slope. So you'll have a few of those as well when you come to class tomorrow. A real life situation, and this is really where we'll focus in on a lot of the applications in the slope-intercept form and identifying different parts. But something we do need to recall is this f of x. It's just a function called f equals mx plus b. This is still considered slope-intercept form because we have m and we have b. We have our slope and our intercept. One of the most important things is right here. Make sure this is written down. In an application, the following are true. The slope, obviously represented by m, represents the rate of change in y. Okay, it represents how quickly something is changing. The b, our y-intercept, represents the original amount, your starting point. So if you have money in a bank account, say you have $50 to start, that would be your b. And then the $10 you add each week, that would be your slope, just as a basic example there. So let's take a look here. Here is one of these application examples, and we can use y equals mx plus b here. That's no problem. But you're traveling home at a speed of 50 miles per hour. You start 200 miles from home. Write and interpret an equation that models your distance from home. So I'm going to let y equal the distance from home. The distance from home. And X will represent the time driving. So our equation will start with y equals, since the distance away from home is decreasing, our slope is negative 50 miles per hour. So that's negative 50x. And then we start 200 miles away from home. So we add that 200 there. So the 200, our y-intercept, is how far we are from home to start at the beginning. The negative 50, the reason it's negative, is that distance away from home is decreasing. If we drive 1 hour, we'll be 150 miles away from home. If we drive 2 hours, we'll be 100 miles away from home. So as you can see, as x increases by 1, the distance away from home decreases by 50 miles. I believe that's our last example. Yes, it is. So that's all you have for tonight. Make sure you have these examples down. They are excellent examples for the 3 ways you'll have to use equations in slope-intercept form in this section. So make sure you have these down, and we'll use them tomorrow during class. Have a great night.